Welcome everyone to week 7 of assembly packaging and sterile storage of medical devices. This week we'll focus specifically on rigid container systems, which are one of the most important sterile barrier systems used in hospitals. So here are our key learning outcomes for this session. We'll start by identifying the purpose and function of rigid container systems. We'll describe their components and construction and how those affect performance. We'll review the cleaning, inspection, and assembly process for containers. We'll also go over loading, unloading, and storage best practices. And finally, we'll finish with quality assurance and testing requirements, which ensure that these systems maintain sterility and meet regulatory standards. So sterilization containers are designed to hold and protect surgical instruments through the entire sterilization, transport, and storage process. They eliminate the need for external wraps, which helps reduce waste and improve workflow. So external wraps includes SMS wraps, reusable, disposable. So these containers provide a sterile barrier that protects the contents from contamination until they're opened in the operating room or other clinical departments. So the design allows sterilant penetration and air evacuation while maintaining sterility once the cycle is complete. So while it's important for sterilant to penetrate the containers must also be designed to allow the sterilant to safely exit. So you can't have the sterilant trapped in there, and that's why it's important that containers have these holes in them that allows this. So common types are validated for steam, gas, ethylene oxide, hydrogen peroxide sterilization. So let's look at the evolution of sterilization containers. Rigid container systems have been around for more than a century, since let's say late 1800s. So the company AceQLab is credited with creating the first sterilization containers back in the 1890s. So the early models were made of stainless steel, which is heavy but very durable. They represented a major shift away from wrapping instruments in textiles or simple coverings. So this innovation actually improved both protection and sterility assurance during transport and storage. So modern containers have evolved to include lighter weight materials such as aluminum, integrated filters, valves, and locking mechanisms for enhanced reliability. So the locking mechanisms on sterilization containers actually tell us that it hasn't been tampered with and that sterility was not compromised as a result. And now modern container structure. So today's containers are usually made of anodized aluminum or stainless steel. Stainless steel is still quite rare compared to aluminum. That's because aluminum is actually lighter weight. But still, both aluminum and stainless steel are compatible with sterilant exposure and long-term reuse. So for steam, hydrogen peroxide, ETO specifically, stainless steel and aluminum are good to be exposed to them in long term. Each container has two major parts, a lid and the base that fit together with a tight airtight seal. So it always comes with a base like this and a lid. Now of course it comes with internal trays or baskets. which hold the surgical instruments. You can also see filter plates, valves, gaskets, and blocking mechanisms. So these are the blocking mechanisms, and this thing you see here is the filter. So all of these work together to maintain the sterile barrier. So some designs include label holders for data cards and identification tags to help track set name and sterilization details. But these data cards that go inside these little nooks are actually more of a permanent solution, which hospitals do not like to use because it makes it so, let's say the data card says here that this container is specifically for orthopedic instruments. Uh, from then on, you would have to match the tray contents with the container name, which does eat up the time of the technician because let's say you built your tray already, but the container wasn't disinfected yet. You would have to wait for the tray to go through the washer disinfector to dry up before you could put the tray inside the container, which is it really messes with the workflow in the MDRD. So a lot of hospitals nowadays we don't bother putting data labels on the containers itself, and in fact we would rather put the printable labels. We would just attach it to the handles of the containers, which allows nurses to know what the contents are, what the tray set name is inside, who built it, when it was sterilized, if it was sterilized, etc. So every component in this structure has to support air removal, sterile penetration, and full drying after the cycle. So functional design features. So solid bottom containers are actually optimized for vacuum or pre-vacuum steam cycles. So what you see here is a solid bottom container. There are some containers that also have this perforation on the bottom of it, and typically those are saved for the bigger containers, ones that require um, you know, added sterilant penetration and air evacuation. But anyway, since solid bottom models depend on vacuum phases for air removal, you don't need filters on both ends, only at the top, depending on the design. Each model must be validated for specific sterilant types. You'll often see designs for steam, ETO, and hydrogen peroxide systems such as Sterid or VH Pro. So these features ensure that even after sterilization, the barrier remains intact during handling and storage. So this functional design makes rigid containers versatile, durable, and ideal for high volume hospital use. To add to that, so for most hydrogen peroxide containers, if we are using rigid containers, they always have perforations on the bottom for filters, and that's because they don't have vacuum phases for the most part. And so it's important that when you're using rigid containers for hydrogen peroxide systems, they always have a perforation on the bottom and a spot for placing filters in. So advantages and protection. So rigid containers offer excellent physical protection for surgical instruments. They prevent punctures and tears that are quite common in wrapped sets. The hard shell protects against drops, pressure, and environmental exposure. Um, on that note, if you were to drop the rigid container, they would be considered contaminated and you would have to send them to decontam again to reprocess. So they also protect the sterile contents from moisture, dust, and handling damage. When properly sealed and stored, they maintain a longer shelf life without compromising sterility. So this level of protection is one of the main reasons why many facilities have transitioned from wrapped sets to containerized systems. So advantages, efficiency, and variety. So rigid containers improve efficiency throughout the reprocessing workflow. Because they eliminate wrapping, they reduce the time required for packaging. They're reusable, which lowers long-term supply costs. Containers are available in a variety of sizes and configurations, so they can accommodate instrument sets for different specialties. So most manufacturers offer modular designs, allowing multiple baskets or inserts to be stacked on top of each other for each surgical team's needs. So this flexibility actually helps technicians organize instruments consistently and speeds up setup in the operating room. Of course, there are disadvantages to containers too. So although containers have many the disadvantages, the limitations are there. They're heavier than wrapped sets, which can increase strain for technicians if not lifted properly. So the initial purchase cost is higher, though offset by reusability. Improper cleaning or maintenance can lead to corrosion, filter blockage, or gasket wear, which compromises sterility. If filters or valves are damaged, they can actually trap moisture or fail to maintain a seal, which compromises sterility once again. So that's why strict adherence to inspection and maintenance schedules is essential for safety and compliance when using containerized systems. So some key design features. For a container to function properly, several design features must meet regulatory standards. So the lid and base must align perfectly to form a complete airtight seal. Containers are built from Sterile compatible materials like anodized aluminum or stainless steel. Containers are also fitted with secure latches and gasket seals that prevent contamination once the sterilization is complete. And of course, it must allow for proper sterile penetration, air evacuation, and drying during the cycle. So most containers include label or data card holders for set identification and tracking. So all of these design requirements are outlined under CSA standards Z314, which ensures safe and consistent performance. So essential requirements for rigid container systems. Every rigid container system must meet specific essential requirements as mentioned, which is set by CSA Z314. First, each container must have an external indicator so that exposure to sterilization can be confirmed visually from the get-go. So when the nurses receive any instrument sets within rigid containers, they must either have a tape like this or the tamper evidence seal. So usually when you're building an assembly, it comes with a blue sticker on it. Once it goes through a sterilization cycle, this blue seal will turn black. So the carrying handles of container systems must support the whole weight of the instrument safely during transport. And of course, inside the design must allow for even circulation of sterilant throughout all areas of the tray. So one area of the tray can't receive all of the sterilant, otherwise it's not sterile at all. And of course, the manufacturer must supply validation documentation for every process. So that includes sterilization cycles, filter use, and loading methods. So beyond essential features, containers must meet several construction standards that guarantee safety and durability. So each container must actually include permanent identification marks, which is usually engraved or etched for traceability and tracking. So these are usually clear markings for sterilization compatibility, so whether they're approved for steam, ETO, or hydrogen peroxide. If you look closely here, it should say low temperature sterilization here, but it's kind of hard to see. Of course, all surfaces must be smooth, corrosion resistant, and easy to clean. Every unit must be designed to withstand repeated sterilization cycles without losing shape or function. And of course, all models must comply with CSA Z314 and AAMI ST79 standards to ensure reliability in the healthcare environment. Now we'll be looking at decontamination procedures. Step 1. So decontamination starts immediately after a container and its instrument set was used. We say immediately, but typically we allow at least 15 minutes for pre-cleaning before it's transported to decontam. So you always discard single-use filters, and a single-use filter is actually usually this blue colored filter that goes inside this filter holding mechanism. And of course, there are reusable filters. So you would have to clean the reusable filters too, make sure it's free of blood and debris. But I would rather say it's reposable rather than reusable because it does get replaced and disposed of after a certain amount of uses. In one of the hospitals I worked in, it used reusable filters like this one, and how we kept track of the number of uses is by adding a barcode on it. And every time we receive it in assembly, we would scan it, and that would add a use to its number of uses number. Of course, you have to follow MIFU guidelines for disassembly. So some parts like gaskets or valves can only be removed under specific instructions, and for the most part, you as the technician will never have to remove this. Um, I believe only the coordinator or supervisor really has the business to open or replace these parts, and even then, um, we're not really equipped to replace it anyway. So if we were to find a broken gasket, we would just send it out for repair and replacements. And of course, all data cards. So data cards like disposable labels that contain the instrument tray name, the person that built it, the date it was sterilized. All of these labels must be removed. Chemical indicators also, and any other disposable seals, such as filters. So you have to remove this before placing them in the cart washer to prevent debris buildup. So you only take apart accessories when explicitly allowed. Over disassembly can actually lead to damage or missing pieces. Of course, finally, before cleaning, inspect for dents, cracks, or corrosion. Damaged containers should be tagged for repair or replacement. And we have step 2. After you're sure that it's passed the inspection, the very quick inspection, continue with manual or automated cleaning using a neutral pH detergent that's compatible with um, the container's material composition, so be it aluminum or stainless steel. Of course, for that reason, you have to avoid abrasive cleaning tools such as abrasive brushes, pads, or even harsh chemicals, um, as these can actually scratch the surface of the instrument. So back to the manual cleaning that I mentioned. For the most part, we don't do much manual cleaning on containers unless they have hardened blood or other kinds of debris on it. Otherwise, if it looks clean, we put it in the automated cart washer. So aside from that, you have to ensure all areas are, especially corners and crevices near the gasket channels, are thoroughly brushed and rinsed. If the container has filters or valves, you have to verify they're disassembled and cleaned if it's a reusable one. After cleaning, you would have to thoroughly dry the container before they inspect it in the assembly room. Any moisture left behind can lead to corrosion or microbial growth. But anyways, those in decontam are not responsible for that step. It's now the assembly personnel's responsibility to dry it and to make sure there's no moisture left behind when they're assembling their trays inside the containers. And so it's the assembler's job to ensure that the clean containers are visually inspected again before being used for reassembly or so yeah. So now let's look at the visual inspections checklist. Visual inspection is a critical safety step before every use. So you have to begin by inspecting the entire surface for residue, cracks, or corrosion that could compromise function. Check that the latches, hinges, or handles move smoothly without stiffness or looseness. Make sure that the interior basket or trays are intact and free from burrs or sharp edges. Of course, you have to confirm that there are no signs of mechanical stress, such as bending, dents, or uh, warps on the surfaces. And you have to record any defects immediately and remove the container from service if any are found. And on to part two. So next you have to inspect the filter system carefully. So the filter system indicates these. You have to verify that any permanent filters are intact and properly sealed in their housings. Ensure that disposable filter plates are present. So these are disposable filter plates as they hold the disposable filters like so. And you have to ensure that they're in good condition before assembly. Very commonly, we've received complaints from the OR. Um, in some situations, they find that when they open a sterile container, the filter housing actually fell off along with the filter, which makes the instrument set contaminated. And with that said, you have to check every screw, bolt, and rivet to ensure they're clean, tight, and corrosion free. Once inspection is complete, you have to document the results in the inspection log for traceability. So this documentation is actually required for quality assurance and must be retained for audit purposes in the future. So gasket and seal evaluation. So the gasket is probably the most important component for maintaining sterility. You have to inspect the sealing edges closely for dents, chips, or corrosion that could break the airtight seal. So the gasket is actually what allows the container system to be airtight. You have to check that the retention plates and securing mechanisms are undamaged and properly aligned. The gasket itself must be pliable, free of debris, and continuous around the entire lid. So you will have to check the gasket and ensure that there's no cracks, no tears, no punctures to the gasket. And of course, you have to ensure that the gasket itself it did not harden after repetitive sterilization cycles. That is a very common thing you'll see with some gaskets that's been used for a very long time. Eventually, the rubber it's made out of will harden, which makes it not pliable. It's not as soft as it should be. And when you see something like that, like a gasket that's cracked or deformed, you would have to send the container set out for repair. And of course, if you find any failed inspections, you would have to document it and report it immediately according to department policy. Valve and latch function tests. So valves and latches control airflow and seal integrity, so they must work flawlessly. You have to ensure that valves move freely with no stiffness or cracks or dents. On most containers, valves are small round discs located in the center of the lid or base, so it's usually here. You have to test each latch to confirm that it closes tightly and performs a complete seal without force. So these are the latches. Check that the lids and bases match correctly. You never mix components from different container sets. So if we were to compare this upper one here with the silver latches, it's actually meant for steam or higher temperature sterilization methods, while those with gold handles and gold latches, they're actually meant for low temperature sterilization methods such as VH Pro or hydrogen peroxide in short. Um, So you would never use these two together. So any container with faulty or mismatched parts must be repaired or permanently retired from use. And you have to keep a record of all inspections, repairs, and maintenance performed for compliance purposes. So this is very important for you to know. Gold handle is for low temperature. Any silver latches and silver handles are for steam or higher temperature sterilization methods. And now looking at container assembly guidelines. So when you're assembling containers, always begin by selecting the correct size for the instrument set or tray. You should avoid using hug towels, paper liners, or foam inserts inside as they can trap moisture or block sterilant flow. So it's actually okay to place hug towels on the trays itself, so the tray, but never place it below the tray and the container, okay? So you also have to place the internal chemical indicator in the most challenging location for sterilant penetration. And usually the hardest to reach location is the center of the container and tray. You have to also insert the data card into its designated holder. So something like this. You would never tape or write directly onto the surface of the container. So this tray here, so it's actually not a popular one anymore because they tend to break down really quickly. Um, it's to a point where some technicians are even taping these locking mechanisms together so that it doesn't move or get tampered with too easily. So that's why the most popular containerized system right now, I would say, is the AceQLab. Anyways, you just have to remember that the way you build a tray affects sterilant access and will ultimately determine if the sterilization is a success. So container assembly guidelines, step 2. So once the tray is fully assembled, you have to document any missing or incomplete instruments before sealing it. You have to attach tamper evidence seals and an external chemical indicator to confirm exposure. And like I said before, some tamper evidence seals actually have its own external chemical indicator to show exposure to the sterilant. Of course, you have to install disposable filters and secure them firmly with the retention plates. You have to place silicone mats under delicate instruments to prevent movement or vibration damage during transport or even sterile storage. And most importantly, you have to ensure that the total set weight does not exceed 10 kilograms or 22 pounds. But I think I've said a story before where a lot of hospitals actually do not follow this guideline regarding weight, especially for the really heavy instrument sets, um, more more specifically orthopedic sets. And of course, exceeding this weight limit can actually affect drying efficiency and safety during handling. And for that reason, if you were to sterilize any sets exceeding the weight limit, you would have to let it dry for a longer period of time. So assembly validation and restrictions. So all container assemblies must be validated according to the manufacturer's instructions. So nothing should ever be improvised. Only use manufacturer-approved accessories such as filters, seals, valves, or retention plates. So whatever accessories that the container came with, that's what you would have to use. You never place pouches or wraps or any textiles inside the container unless the manufacturer specifically validated that setup. And even if they were to validate that setup, it all depends on the facility that you work for, the healthcare facility. Of course, before sterilization, you have to verify that the lid fits smoothly and that the locking mechanism engages evenly across all sides. So if the lid or base feels uneven, that's a clear indicator that the gasket or frame may have been warped. So you should never force the lid and base together. And of course, preventive maintenance and documentation must always follow MIFU to maintain warranty and compliance. Skipping validation actually risks sterilization failure, and that directly impacts patient safety. Sterilizer loading, best practice of doing so. So during loading, you always position containers flat on the sterilizer cart or shelf, never on their sides. You have to avoid direct contact between containers and the chamber walls inside the sterilizer, as the heat from the wall can cause condensation or buildup of it inside and outside the container. Of course, you do not stack containers unless the manufacturer provides written validation that stacking is permitted. Um, for those of you who didn't know this, some hospitals actually allow stacking of containers, of rigid containers, for efficiency, but a lot of hospitals do not practice this actually. It's a practice that is no longer being exercised because it just makes drying longer. We're just not 100% certain that the containers below the stacked containers, especially the one on the lowest level, we can't guarantee that it's been, sterilized completely and successfully. Of course, another loading practice is that heavier containers are placed on the lower shelves of the sterilizer manifold to prevent tipping or shifting during the cycle. You have to allow enough space between each container so that steam or gas flow can circulate freely. So for me, I use maybe 2 to 3 fingers, which is about 2 inches of space in between them to measure their distance. So you have to remember that improper loading is one of the most common causes of sterilization failure. You have to follow your facility's loading policies and the sterilizer's load configuration guide every single time. But in this case, you have nothing to worry about as a if you were to start as a new technician, you will never do sterilization on your own. You will be shadowing, you will be guided alongside a senior technician. And so there's also unloading and cooling. So once the cycle finishes, you have to leave the containers on the sterilizer cart until they're completely cooled to the touch. So you never try to speed up cooling by using fans or opening vents, for example. Rapid changes to temperature can actually cause condensation inside the tray and container. You have to avoid placing containers near cold walls, vents, or air currents. So if condensation forms, it means moisture has entered the set. That container is no longer considered sterile because it's a wet pack. So you only handle once the load is fully dry and cool to the touch. Moving hot containers can actually distort the gasket, especially with really heavy instruments within containers. And it can also compromise the seals and handles. So cooling in a controlled environment post-sterilization preserves the seal and integrity of the container and sterility of the instruments. So post-sterilization verification. After sterilization, verification begins before any storage or use. So you have to check that the external chemical indicator has changed appropriately. You have to inspect the container surface, make sure that it's clean, dry, and free from moisture or any mist residues. You have to examine all tamper-evident seals to confirm they are intact and unbroken. If a container is moist or has any broken tamper-evident seals, it must be reprocessed immediately. You never wipe down moisture or reuse them. So for immediate use steam sterilization or IUSS, containers must be opened and actually used immediately after the cycle. They are never stored. So IUSS containers are only used in situations where there's already a procedure going on and the surgeon or any OR personnel, for some reason, they dropped the instrument to the ground and that instrument is one of a kind or is being used in another room already and we cannot replenish it for them, they would call a technician to steam, so to flash sterilize that instrument so that they can use it. And it's usually done within 20 to 30 minutes. Of course, IUSS always comes with its own risks, so it's best to not, to avoid the use of it. Proper storage techniques. So you have to store all containers flat, never on their sides to keep gasket from compressing or being compressed and warped as a result. So you have to avoid top shelf containers, storage. Containers are heavy and can cause injury or shelf collapse. So as you see here, a lot of smaller containers and items are actually placed on top. And especially for me, I'm only 5 feet tall. I always struggled to actually pull out items from the high shelves. So it's best to keep smaller instruments at the very top. Of course, you have to use proper body mechanics when lifting. You have to bend your knees, keep the back straight, and hold the container close to your body. We have to apply the first in, first out, or FIFO stock rotation method. So older loads are used before newer ones. So for that reason, when you're putting trays away, let's say you have a space like this, you would have to push the older instrument forward and the newer one in the back so that the older instrument is used for first. Keep the storage area clean, dry, and temperature controlled. Humidity and dust can damage filters and seals. So we already know that it should be within 18 to 22 degrees Celsius and 30% to 60% relative humidity. And of course, it has to be positive air pressure to keep contaminants out. Of course, it's best to label storage racks clearly by sterilization date and set name for quick sterilizability. Um, a lot of hospitals will keep certain aisles for certain specialties, for example. And then sterile transport protocols, part one. So transport of sterile items must always protect the barrier system from damage or contamination. So for that reason, you have to use clean, enclosed, or covered carts dedicated to sterile transport only. You never push sterile containers through soiled or decontamination zones. That is a big no. If you were placing, let's say, if you had a case cart and you had to bring it up to the OR, for example, you never pass the decontam area. There's no reason for you to go through there. For that reason, the hospitals will plan routes so movement is direct and minimal, avoiding unnecessary handling. Of course, there are some situations where, let's say, the closest route to the OR, an elevator is out of service. You would have to take this up with your management and ask them what the best practice is to avoid, longer routes, and so that the case guard with the instruments are not contaminated as a result of that. Of course, you have to handle containers gently. Rough handling or vibration can damage filters, loosen seals, and even um, damage instruments itself, especially fragile ones. You always maintain physical separation between clean and dirty pathways. Like I said, never go through soiled or decontamination zones. Avoid high traffic areas, areas meant for visitors, for patients. You should not be using that. A lot of hospitals will have a dedicated elevator just for OR case carts. So now we're looking at sterile transport protocol part two. Whenever possible, schedule sterile deliveries during low traffic hours to reduce exposure risk. So high traffic hours, I would say would have to be 9 to 5 p.m., for example, 9 a.m. to 5 p.m. So when the afternoon shift count comes in, that's when they actually start building scheduled case cards for the next day. And it takes maybe 30 minutes to build the case cars. During that time, we would probably put it against the wall in the um, distribution room or issuing area. We would put it there until a certain time when it's safe, especially for hospitals without any dedicated OR clean elevators. We would wait until the high foot traffic disappears and we would send it up maybe like 5 p.m., 6 p.m. That's a good time. And like I said, avoid sharing elevators with waste, food, or even linen carts, as those actually carry contamination risks. When transporting off-site, you have to separate clean and contaminate items completely. So there are actually some companies that their main service is to sterilize instruments. One example is Sterile, and I urge you guys to search this up. Sterile, they transport off-site, meaning they will have clients, either clinics or even hospitals and other healthcare facilities. They would be sent dirty instruments, and it's their job to clean it for their clients and then send it to their clients in a timely and clean manner. So after each soil delivery, you have to ensure that the vehicle is actually disinfected before reuse. So vehicle could be the case cart itself or even the truck, for example, that's delivering them off-site. You always follow provincial and federal biohazard transport guidelines. These are non-negotiable for patient safety. So transfer to sterile field. So before the case, confirm that the set name and label match the surgical procedure. listed. And with that said, if you were in the issuing or distribution role, you would have to follow surgeon preference cards and build the case cards as needed. You have to visually check that the tamper seal and external chemical indicators are intact. You have to place the container on a flat, dry, sterile surface. So typically inside a case card. So you never place it on wet drapes or uneven stands. So now we're moving towards the surgical scrub rolls role and tasks. You know what they do inside the OR field to prep the instruments. And so they would have to verify that the information card is present, legible, and matches the OR schedule. They have to maintain aseptic techniques throughout setup. This is the last opportunity to catch any integrity issue before the field is opened. So it's the scrub nurse or scrub tech's job to make sure that the MDRD did their job properly and that everything is opened aseptically. So I have a video here that I recommend you guys watch. It just shows a brief look at how surgical technicians or scrub nurses set up the sterile field. So how they gown up, for example, and how they drape the tables that in preparation for setting up instruments. So these tables are where they will be placing instruments, for example, all the trays, wrap trays, pouches. All right, so after that, it's aseptic opening. So aseptic opening, as you should know by now, is the process of opening sterile packaging without introducing microorganisms to maintain the sterility of its contents. So for that reason, scrub nurses should be fully gowned up and gloved up already. So when they're opening, the scrub nurse removes the tamper-evident seal carefully without contaminating the container. They would open the lid away from the sterile field to prevent airborne contamination. They would inspect the filters, valves, and gaskets. They would inspect that it's all intact for cleanliness and integrity before handing off the tray to their colleague. So they would then check that the internal chemical indicator inside the basket has achieved the correct color change. And then, of course, the scrub nurse then removes the inner basket and places instruments on the sterile table using sterile techniques. This step confirms the success of sterilization and the maintenance of the sterile barrier up to the point of use. So handling contaminated containers. So after the case, all soiled instruments must be returned in their original rigid container. They would have to securely close and latch the lid before transport. If the so sorry, I should have said this. This is after the procedure has already been done. So if the exterior is clean, there's no need for an additional wrap or cover, and you would transport the container directly to the decontamination area. Never place it in hallways or mixed storage zones. You would just follow your facility and IPAC policies. Um, and of course your MDR decontamination workflow guidelines. With that said, though, some facilities lids are actually left off containers after use for technician safety. This allows quick visual confirmation of contents and prevents unnecessarily handling, especially if there's sharp instruments inside. It's best if the technician that's transporting it doesn't touch the contents inside as much as possible. Of course, quality assurance overview, part one. So every MDR department must have a quality assurance program to verify that sterilization processes remain consistent and effective. So quality assurance ensures that the container system maintains sterility until the point of use. That's essentially the ultimate goal of containerized systems and sterility barrier systems. Part of quality assurance includes verifying load configuration, sterile penetration, and overall cycle performance. So we use chemical, biological indicators, physical indicators routinely to monitor whether sterilization parameters were achieved. And so every cycle must be documented. This includes sterilization printouts, load contents, and operator initials. Finally, facilities must conduct annual audits for process validation. So we have to validate that procedures are being followed and that equipment remains in proper working conditions. And now to part two. So before every use, the container should go through a visual quality assurance inspection. Check the gasket and seals for elasticity and continuity, no cracks, gaps, or embedded debris. Look for structural damage like bent corners, loose rivets, or corrosion on the metal. Verify that the filter installation is correct and that no filters are missing or reversed. You have to ensure that all fasteners, latches, and hinges are secure and functional. And you have to place chemical indicators in the most challenging area of the load to get an accurate representation of sterilant contact. These checks confirm that the set is safe for sterilization and that sterility can be properly maintained. And now to container validation testing. So validation testing confirms that the container system and sterilization process are performing as intended. Testing must be performed whenever new instrument sets are introduced. It's also required if there are any design changes to filters, gaskets, or other components. If the set configuration or weight increases, revalidation is necessary. Heavier loads affect airflow and drying. So if for some reason you are the coordinator and there's a new instrument set required or asked for by a surgeon, so they want it to be in circulation, you would have to put them through validation testing, especially if they're using rigid containers as their main setup. You would have to do that. You would have to make sure that its layout works properly to allow sterilant penetration. If it's multiple levels of trays, you would have to test those too. Everything has to be accounted for. So validation testing verifies both sterilization efficacy and system compatibility. So you, as usual, will follow CSA Z314 and AAMI ST79 standards for all validation procedures. And of course, we have random testing programs or annual checks. So apart from the initial validation of the containerized systems, facilities are required to conduct annual random testing. This typically involves biological indicator testing to confirm sterilization integrity. Random testing is also performed anytime the system undergoes a major change. So, for example, after a new sterilizer is installed, or after a major repair or relocation of sterilizers, or sterile storage system, or when steam supply parameters have changed inside the facility. So the goal of random testing is to verify continued compliance with sterilization standards and environmental conditions. It's a proactive step that ensures reliability before any failure can occur. So random testing documentation. Documentation is critical for traceability purposes and accreditation compliance. Every random test recorded must include the date, the set name, weight, and load position. You have to include the load position within the sterilizer, top, middle, or bottom rack, since this can actually influence the results. You would have to list the sterilization method used and attach any printout parameters from the sterilizer. You have to record indicator results, both chemical and biological, and describe any follow-up actions if results were abnormal. Every entry must include the technician's name and signature for accountability. So these records are reviewed during audits and accreditation visits to prove that sterilization processes are consistent and well monitored. So now let's look at summary and key takeaways. Let's summarize what we've learned in week 7 thus far. So there's no single packaging method that suits all medical devices. Selection depends on the device design, sterilization methods, proper handling, cleaning, and assembly of containers are key to maintaining sterility assurance. Every MDR technician must understand how to load, how to inspect, how to test the container systems, and how to assemble these systems correctly. So accuracy and attention to detail protect both instruments and patients. Each of these steps, from decontamination to quality assurance, plays a role in the overall chain of infection prevention. So safe body mechanics and material handling. So containers are often heavy and very awkward to lift, so it's important to know safe body mechanics. So you always have to bend your knees and keep your back straight when lifting or lowering containers. Avoid twisting your spine. Instead, turn your entire body with your feet. Ask for help when lifting oversized or heavy containers. Never try to move them alone. You must use carts and trolleys whenever possible to avoid physical strain. Keep the floor dry and paths clear, free of clutter to prevent slips or falls. For this reason, actually, a lot of the time, environmental services, so those are the cleaners, they are only allowed access in the MDRD when there's low foot traffic. So that would be during the night shift, for example. I recall several times it would be 10 p.m. So I would be working 3 to 11 p.m. By 10 p.m., it's already, it's calmed down a bit in the department, and that's when the environmental services usually comes in to clean up our department. That's when they would use um, wet mops, for example. All right, so these safety habits protect you from injury and also prevents, accidental dropping or contamination of sterile items. And that's the end of the slides for today. So just remember, rigid sterilization containers. They provide a durable, reusable sterile barrier system that maintains sterility from processing all the way to patient use. The quality of your work directly improves and influences surgical outcomes. So it's important for you to know how to inspect these sterile barrier systems. All right, so that's all for today. I'm so sorry I had to cancel our Sunday classes. Um, Good news is I am starting to feel better, but thank you so much for understanding, guys. Please make sure you look at the week 7 assessments, and I'll see you guys again next week. Thank you so much. Have a good one.